Okay, guys, massive pleasure to have you guys in this particular session. And I'm also going to be making some kind of batched videos because we'll definitely be running it in batches. And today we're going to be talking about machine learning in public health research. So I believe everybody that will be getting to understand what the fundamentals of this course is. We are definitely going to be working with a project, okay? I will be working with the project, so I still have other sessions maybe later on. So I'm just doing it in batch. Okay, that's fine. So machine learning, if you look at the outline that I did share sometime last week, if you take a look at this outline, you see that we've got some kind of learning outcomes that we are expected to complete on the course of this particular interaction. We'll start with what was the foundation of machine learning, what machine learning is all about. Then we look at a couple of stuffs like trying to understand the intricacies in programming, look at statistics and all of that. But the end point is that we want to make sure you guys have the capacity to work on your project with this particular knowledge skill that you get. And also beyond working on your project with this skill, you can also use it in other real life applications. Good knowledge from what I'm going to explain to you now means that you have the capacity to develop ChatGPT, an app like ChatGPT. You can develop Grok. You can use libraries like TensorFlow to develop, you know, very interactive chatbots, applications that can detect any kind of information, detect fake news, detect if an image is an AI generated image or not. So just look at this beyond the scope of you working on your project, okay? Because we have about nine students that should be here, right? Nine research students that should be here. But the idea is that we need to look at machine learning as an extended scope. Now, the reason why I actually put public health research here is that I want you to understand it from the perspective of your project. And this is the best time anybody can learn machine learning, particularly if you're working on a project right now. So that means that your data analysis, your methodology, everything that's going to be reflected there is purely machine learning. The similarity between you and your colleagues is just basically going to be in your chapter 1 and 2, where you guys will discuss literature. But from chapter 3 down is different because everything you're doing is methodology, is machine learning. Essentially, from this scale, like I said, you can now further it, right? Start doing natural language processing, know how to interpret voice cloning. Like this is a very massive scale anybody can have, right? And beyond the shores of your PhD, sorry, beyond the shores of your academics, right? You can basically work on a lot of things. So I'm just going to reiterate again. So on the course of our 30 days session, this is just day one, we are going to, along the line, definitely individuals definitely going to join us, but the idea is that along the line, we will not just understand how to do machine learning, but we'll also develop capacities in other areas like data analysis, data visualization, mathematics, slight mathematics, not really serious mathematics, just slight mathematics and statistics. So it means you're getting four in one skills. That's what machine learning is. Machine learning is like you're trying to join four skills in one, and it's a lot of advantage. It means that you've now understand data visualization and even you've understood how to interpret a lot of statistical data. And that's one of the very massive pathways to becoming self-employed and basically make money. Because right now, if you've got the skills, it's a lot, right? It pays you. I'm sure you don't want to, you don't just want to work in an environment that is not really going to be very favorable for you. So I think that's that for the explanation. I'm just going to go straight into uh, into the conversation right now so that we can get started. Now, so what are we definitely going to understand today? So today, I'm not going to open Python. I'm not going to open any visualization tool. It's just going to be purely based on explanations to help us gravitate to the fundamentals. Just like I also explained, I'm also going to be making YouTube videos that I'm definitely going to be putting on my channel, and I'm going to be sharing them across with you guys. Okay. It's just a journey that starts from one day. And as well, I'm going to be leaving you guys with some kind of exercises to practice, okay? So I can develop yourself hands-on on it. Because right now, one of the trending skills as we speak now is artificial intelligence. And yeah, that's a lot. So by the end of this session, remember, each time we're having any conversation here, just bear it in mind that you have a project topic at hand. Now, when we talk about project topic, we're not talking about a student in an undergraduate. We're talking about anybody, right? Anybody. In my PhD, I'm looking at how to use deep learning models for image recognition. And that is purely what? A subset of machine learning, which is going to stem from here. So that's an application that can be deployed. So even if whether you're a student or not, you can still look at this session from you want to develop a real-time project that you can scale. Do you understand? A project that you will scale, GIA, use it and collect money from people. Because most of us, you pay for subscriptions for open AI subscriptions, and that's a lot of money. Okay, so, all right. So now what are we going to understand today? Now, first of all, I'm going to explain some of the core concepts, right? So we develop some kind of a clear, intuitive understanding of what machine learning is and how it differs from traditional statistics, right? And some of the rule-based programming techniques that we have. So I'm just going to try to create that kind of discrepancy between machine learning and that. Now, from the public health perspective, I'm going to look at why machine learning matters specifically for public health challenges, right? Some stuff like disease surveillance, treatment decisions, resource allocation, and all of that. Then I'm also going to talk about some kind of realistic expectations that distinguishes between machine learning, what machine learning can do, and what machine learning cannot do. So we're just going to keep this session very, 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 very. Okay, sorry. I don't just know why that seems to be. Let me just keep it there. Now, I'm just going to kind of distinguish between machine learning, what machine learning can actually do and what it can do. Now, the first time we met, one of the first things we talked about was what's our experience about using AI? And a lot of us talked about, oh, I've used AI today. I used it to ask a question. I asked the chatbot to do this and all of that. Now, we're going to talk about how that actually really works and what happens behind the scenes. So this is just basically a theoretical session. You don't have to worry. Don't worry. I'm just going to keep everything very simple in terms of discussion, just for us to have an idea of the kind of relationship we are stepping into. Now, why does machine learning matter in public health? Now, this is just like a kind of, this is just more like an explanation. Okay, we are talking about machine learning. We have machine learning in optometry. We have machine learning in engineering. We have machine learning in computer science. We have machine learning here. Now, what of public health? Someone that chose, I want to do machine learning prediction of Neisseria gonorrhea, why does it really matter in public health? That's the question. Now, remember that before I talk about machine learning, normally we usually talk about data statistics, data analysis, why it matters in public health. And now, before I bring in machine learning into the question, we usually see that data analysis or statistics, they matter in public health because of what? They help in informing decision making. Now, if you say 300 students have HIV and AIDS in Imo State. Now, that's a broad question, right? That's a statement. And that statement wouldn't have been possible to make or to be quantified without that number, 300. So what data does is that what it tells you that what okay, if you're sending antiretroviral or highly active antiretroviral therapy to hemostate, take it to what 300, take 300 anti highly active antiretroviral therapy to what to hemostate. That is data, right? So essentially, that is what data means. Now, what about machine learning now? Now, we say that data helps in informing decision, right? Because that will help us to make a decision of, okay, when I'm going to demonstrate, I'm going to go with 300 uh, highly antiretroviral kit or whatever bullshit that is. But the point in this video now is that in terms of machine learning, which we haven't defined yet, public health systems are stuff are where we generate some kind of those data, like I just said now, right? Somebody can say patients' records about cancer, lab records, genomic sequences, just like we are going to be working on practical projects in this session, where we're going to be working with some kind of African biodata bank and all of that, right? So some people have already recorded something in a CSV file, comma separated value. And then we'll have to now take that file and try and analyze it to get some kind of insights, then allow machine learning models to now predict insights from that particular data sheet. So that is just what it is. So machine learning in public health helps us to make decisions faster. It helps a doctor. So let's say, for example, now a doctor, the girl that was bitten by a snake, right? Let's say, for example, when the girl came into the facility, I'm sure, did all of us hear about that incident?
Yes, I did.
Okay, good. Now, when she now comes into the facility, so what happens? So basically, what machine learning models could do is that when she makes complaints, machine learning will now go through previous records of people that have made that kind of complaint and predict the type of venom that beats her, then recommend a particular type of whatever treatment regimen that's going to be used. That's just like the fundamental idea of what machine learning is. Like that is just what it is. Unlike traditional methods where we have to okay, start testing the person again and all of that. But in terms of machine learning, we take in data, put it into the computer. The computer will now use its own hand and predict what that thing would be. So that's more like saving the doctor's time for try and error. So that's just basically the idea behind what machine learning. So we just need to actually understand the stuff of this uh, entire concept. This is just what it is. Okay, that's just a picture. So I don't really want to read so much slides. I love coding, entering into the environment and messing things up. But for now, we just need to have a kind of grasp of what it's talking about. The traditional method is, where you try to analyze the case. Okay, you book the person for laboratory session and all of that. But with the advance of machine learning now and learning from data, it makes decision making like what easier for public health practitioners. So in that situation of delay, that is going to be really, really, really very possible, and that is where machine learning models will make it easier for prediction of timely diagnosis and help in faster decision making. So I'm sure that that really makes a lot of sense. So this is just the theory. So growing data volume, it makes it important for machine learning. That remember we're talking about why it matters because the more we are having a lot of data, there is data from football, there is data from the hospital, there is data from marketers, there is data from agriculture, there is data from social scientists, there is data from a wide array of areas. This now makes it important that for us to be doing traditional data analysis in class, where we'll do, okay, we'll put all this on questionnaire and analyze and all of that, is really going to be time consuming. So that means we need to develop models that will just feed in that data. Automatically, the model will predict what the outcome would be. That is just the idea behind what machine learning. particularly in what in public health and in other what sectors. So time pressure, complex relationships. Most times, you're trying to do data analysis, and your supervisor is saying, okay, you need to use time series, you need to use uh, ANOVA and all of that. But there could be some kind of complexities in the type of data set you've got. And in this scenario, you can also import a model and use it to, basically walk over what you want to do. And this is actually one of the very massive advantage that machine learning offers. So now I think more like the class starts now. And now we now ask the question now, what is machine learning, right? What is this machine learning that we're talking about? We've studied a lot of them about machine learning, but practically, what's the definition of machine learning? I think this is just the first and last time I'm definitely going to define this. If you look at the course outline, you see that we have like it's day by day till 31st of March. So it's important for you to understand what machine learning is. Go over these slides. Definitely, we're going to share it. And yeah, the next level is another 10, and that's that for. So yeah, so this is just going to be the time I'm going to explain what machine learning is all about. And I believe from other prior explanations, it's still definitely going to sync very well. So when we say machine learning, it's just like the practice of using algorithms to predict and learn patterns from data, right? Then we'll now use those learned patterns to make predictions or decisions about new and seen data. Now, what is this? Now, let's look at it from the case of ChatGPT. Or before that, let me explain what traditional programming does. Now, unlike in traditional programming, right, human beings write explicit rules. They'll say if somebody's temperature is greater than 38, then there is possibilities of fever. Now, but what machine learning will do now is that it's possible that there could be some other outcomes that the person have, right? That it will now have to do what learn from. Do you get? So basically, what machine learning does is to do what? Learn from history. Now, the reason why you're behaving now is because of what you learned from your past friends, probably your exes and all of that, right? So the kind of behavior they had, then you probably dated another person, or you dated another person, or yeah, probably anything of such. But essentially, from there, what happens is that you now develop into a model because you've been trained with experience. So when you meet somebody new, right? The reason why you meet someone and say this person is a red flag, you are now a machine learning model. You're a model because you've learned from past data. Now, when that person coming to you now is just like feeding you a data, the person is like a new data. So immediately the person comes with all the person's stories, talks. Those talks now are the input. Something like the tables, the columns, the age. Maybe it's supposed to say age is this, height is this, color is this, language is this, whatever. All those things about the person is like the features, which we'll explain later. Okay, I'm going to talk about that later, and we'll definitely understand machine learning to the bone marrows. Now, when the person talks to you, what do? You say, oh, no. I know where this guy, I'll place him. I know where this guy will be placed. This one is a simp. How did you know somebody that is a simp? They didn't just, there is no 18-year-old that knows a simp. Or there is no 16-year-old who is dating for the first time that would automatically know a simp. How you know a simp is because of you've been trained on experiences, right? So what we do now is that we use algorithms to learn patterns. So we'll explain several algorithms. We have K-nearest neighbors, we have naive Bayes, that's the Gaussian naive Bayes. We have logistic regression. We have decision trees classifier. We have the random forest classifier. We have neural networks. We have many of them. We have clustering, PCA, principal component analysis. So these are several algorithms that we use in doing what? In learning from our data. So that means, let's say for example now, if you bring something like images to me now, to learn from all these images before you now feed it an image and predict which one is a cat. The type of model I will use for that particular learning of that images is different from the type of model that I will use for when you give me let's say a data sheet that contains HIV positive women in Akwa, Abia State. Then I should learn from this pattern of data. Then when you now give me a fresh data of somebody, it will now predict, is this person HIV positive or negative? Remember, I'm developing you guys to become engineers because the goal is for us to become machine learning engineers. And as engineers, we need to think very critically. So what it means is that it's the computer, the algorithm, right? Your TikTok algorithm, your Facebook algorithm learns on all these patterns. It learns on all the data, right? So when it learns from it, it can now be able to now make prediction that this is a cat, this is a dog, this is an animal, this is an idiot, or this is this. Do you understand? That is how it works. So when the guy now meets you when you're 24 or 25, no, this guy is not a serious person because of what? You have already been trained from algorithm. So on the course of this session, I will be talking about what we call accuracy. When we know if the model is accurate, or when we know if the model is if the model is precise. I also teach you guys those terminologies: precision, accuracy, recall score, F1 score, classification report. These are terminologies that we use in knowing if truly when you predict this to be a cat, because I'm seeing you guys as engineers now. When we start deploying models, when you say, okay, this is a cat, is it truly to what percentage are you a cat? Because machine learning tends to make what? Mistakes as well. So just think about it like teaching someone to identify birds. So you not really write down all the possible rules about, beak shape, when the beak is like this, when the feather is this color, when the size is this, when the inside is this. You show so many things. When you do that, somebody might now go and bring a vulture that you've never seen before. In normal programming, this is what you would do, right? But in machine learning, we feed it with so many data. Then we now save the model, then now serve it data. You see how we serve it data. And then we'll now ask it to predict what this boy is. You now predict, oh, this boy is not a simp. Simp or not a simp. Okay, and then there could be some other ones that will not predict binary. They might predict based on numbers. Maybe you predicting the crypto price, because from this information you can still be able to develop chatbots that can predict the price of crypto tomorrow based on all the information it will gather from trends, news, flash, and all of that. Then it can be able to deploy, okay, this is where this is where the line is going to be, the line of best fit is going to be tomorrow. And then based on that, you feed it with much data as well, and it still predicts. So this is how all of this works. So I just hope we've understood the orientation. Your brain has format, like your brain needs to be working on that. Okay, this is me now in my project. I want to predict maybe the presence of that particular disease or infection in a data set using information from other data sets. And it's really a very interesting project to work on because you sit at home to work on it. You don't need to go into the field to do machine learning. You don't really need to go into the field. Yeah, I know for mine, I have to go into the field because I'm collecting data from people who have manifestations of skin manifestations of neglected tropical diseases. But then I can still download the biobank data sheet online, then use it to train my model. So it's a very, very fantastic project. Some people, it looks like, oh, I've been with systematic reviews. I've been in systematic review for the past 5 years. And yeah, it's the type of research that keeps you at home as well. And now machine learning is still keeping me at home. So it's a very interesting project to work on, guys. And I'm seeing it beyond what you're thinking. So it's not just a project now, but it is the insights that it comes with. And let's go to the next one. Since we've now understood what machine learning is, now what is machine learning not? So in our mind now, we've already taken, oh, machine learning is everything. Machine learning is my X. Machine learning is all the characters that was displayed. And currently now, when you meet a new person and he says one or two things, automatically the algorithm in you, probably in your body, you're using naive bias, or you're using logistic regression. You classify him immediately. This is what you are because of what you've been trained on. But now let's talk about what machine learning it's not. Now, the truth is that machine learning is not magic, right? So I actually just detailed it here. Machine learning follows mathematical principles. So what it just does is that it just tries to find statistical patterns in data, nothing mystical. If patterns don't exist in your data set, then there will be no algorithm will create them. So it's not that it works with magic, right? Results depend entirely on the quality and representativeness of your data. So now let's take, for example, now when you open your YouTube, what type of video do you search? First search. You open your YouTube, the next thing you search is you search uh maybe Domon, or you search Akanchawa Jesus, or you search mostly music videos, right? Christian music videos. You play Christian songs, right? You're a Christian. That's good, that's fine. Now, since you're a Christian and those are actually some of the videos you search for on YouTube, essentially, what do you think the algorithm does? Now, the algorithm now is now taking based on your data, your input. So when we are building the UI component of the app that we are deploying, now there's a particular area where we do, okay, we use JavaScript to write event handling, right? So it will have to now incorporate all the possible features that will allow participants to enter data in the form or in any catalog, right? Probably you're watching Netflix and you're searching for movies. Now, what does YouTube have? YouTube, when you are registering for YouTube or Google, you continued with Google. That's fine. You put in your age, your gender, your location, you're in Nigeria. Shey, those are actually the information that you filled in. You put in your race, probably, I doubt. Now, all these informations that you put in, what happens? When you now start searching for information, so YouTube will be, okay, someone that is 21 years old, or someone that is still a female, and someone that is in Nigeria is searching for the mom. So that's like the algorithm, you're feeding the algorithm with what information. The algorithm is mastering, okay, this girl keeps searching for this thing. Then the next time you just refresh your YouTube, what will happen? It starts showing you similar ones, how to start a relationship, how to fall in love, and all of that, right? So it's based on the patterns that it's learned. So what the point you're trying to say is that it doesn't work by magic. It's not magic. It's just based on the pattern. If you open a new YouTube account, at first it will not show anything. It won't show anything. Even if it wants to show something, that thing must be based on data. Either it's based on, okay, you registered from somebody in Nigeria, it will now show you very dark goat, right? Then you now probably start watching it and messing up. But it's not really going to show you anything until the first thing you type. If you type PHP, introduction to PHP, or introduction to Ruby on Rails, or introduction to Python programming, or programming in Python, automatically it will now start showing you similar videos. And the same thing also happens on YouTube, right? The type of things you search for will give you, it will appear in your feed. So not automatic intelligence based on patterns. I'm not really going to repeat myself. I think that's just the thing. So it's not independent of assumptions. So every machine learning model makes assumptions about data structure, feature relationship. So this feature now means your character, your age, your your school, if you enter that in the form, your location, all those information, right? And the patterns, just basically that's just what it is, okay? Yeah, so not more theory here. Now, this is where the game now comes in. Now, we will now talk about artificial intelligence versus machine learning versus data science. I just want you to take a look at this for a second. Now, basically, thank you, so I'm back. Now, basically, these terms are actually used interchangeably, right? And one of the problems we will have in this discipline is that, there are so many conflicts. There are conflicting insights. When you go on YouTube, you see an AI course for 100 hours. You see another one for 48 hours. You see another one for 13 hours, 2 hours, 1 hour crash course, 2 hours crash course and all of that. And it's quite difficult for you to know where to start. Okay. But that's definitely what I'm going to explain here. Now, in the world of data, this is what I'm going to look at it now from essential. Everything here is the world of data. Now, we have artificial intelligence, and artificial intelligence is the one that is at the outermost part, right? It's just like the circumference, like rubbing on around the circumference of this particular what, of this object here. Now, artificial intelligence now, this is just like the broadest ecosystem of everything. So artificial intelligence just tries to understand how computers can perform human-like tasks. So when you open your phone now and you say, hi, Siri, it will say something. Or you open your phone and type two, I want to come. It will write it on your keyboard. Normally, human-like, you can use your hand to write it and give it to the person somewhere, right? But now it's your phone that is doing it and sending it to the person. So just the whole ecosystem of everything is what AI. When we talk about AI, this is just the ecosystem. Now, the broadest concept now, any system that performs tasks typically requiring human intelligence includes rule-based systems, gaming algorithms, machine learning model, and all of that. That's all we call AI. Now, machine learning now is just like a subset of AI. It's not inside of it. Now look at machine learning now as the circumference of this black circle. So that is where algorithms now learn from that. That is just like okay, normally your phone is typing and you're sending messages with your phone. Now, what about if you say, Siri, give me the latest song that I played yesterday or that came out today? It will now search from data, learn, use algorithms, go through data and all of that, right? And understand from several people's perspective of what they are defining as latest song and predict some of the songs and return it back to you. That is what machine learning. Now, whereas data science is just like kind of a broader discipline that combines statistics, programming, and domain knowledge to get insights. It also includes machine learning. So basically, what this training is all about now is the data science training. Because remember that I said we'll touch some part of statistics, we'll touch some part of programming, of course, with Python, and then we'll touch some part of um, data visualization, more like data analysis. So it's just like we'll just try to scratch around the surface, right, of the essential areas to get it. So all these whole horizon of all these complex whole now is what we refer to as what data science. Remember this session, the reason why I'm explaining this way is for us to make sure we hold grasp of what it is really is, because most times, YouTube videos, insights outside of the scope can always be confusing, and you might not really have that roadmap for you to process what you want to do. But I feel like this is always very helpful because it gives you a specific roadmap for you to be able to penetrate what machine learning. A lot of people struggle, right? Getting that particular roadmap to enter into it. But I believe it's something we need to do what we need to be very, 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 very conversant with. So anytime we talk about AI, it's not just AI is not just don't see it as AI is ChatGPT. No, like AI has been in existence since 1950s. Anything that your computer is doing that normally is a human being that can something that the human being should be able to do, a computer is not doing it. It is what it is all what we call what AI. So AI is just like everything, right? So before AI that you're thinking that is ChatGPT came out, it already you are using phone to call your ex by 2008. Those attributes of your phone were already artificial intelligence, right? So machine learning is just now like now. How about we now allow these machines now on their own make predictions, unlike we now using the phone to make the to type, okay, do this, do that on their own. Can these models learn? Can these algorithms learn? And maybe while we feed it with data, it continues to improve its experience and work better for decision making. Another thing I should have talked about is deep learning, right? But I wouldn't really cover that with the scope of this video. So deep learning now is just like now those neurons, those fibers that enhances, that's more like the generation of those outputs. So I wouldn't really go into that, but it's more like a deeper subset of what machine learning. So now, I don't know if you guys can hear me.
Yes, we can.
Was I disconnected at any point?
Yes. When you finish talking about deep learning, or when you just said something about deep learning.
Wow. Okay, all right. So, yes, I think that was the last thing I said. I said I wasn't really going to go so much into deep learning because deep learning is deep learning is more like kind of a subset of machine learning, where we look at those fibers, right? Just look at it like those fibers now that engineer the machine learning process. I think that's going to be a very friendly example, right? So deep learning now is going to is going to consist of those fibers now that enhances that machine learning model. So deep learning is more like a subset of machine learning. So I will really go into much into that because most of the libraries for that, TensorFlow, Keras, and PyTorch and all of that, we wouldn't really go into that. But for now, we're going to work with libraries that can help us do tabular machine learning. So now, just like we continue to discuss machine learning, the difference between machine learning and traditional data analysis is that in traditional data analysis, we just want to know what happened. Basically, we're just trying to actually understand. Okay, I think I just can close this. Okay, we just want to actually understand mostly descriptive questions. Just think about it like you get into the field, you're collecting data, information, and you're like, okay, uh, how many people are HDs? What's the average? What's the mean? What's the median? What's the relationship between this and that? These are actually questions that you're basically answering. It could be inferential, it could be descriptive. What's the average prevalence? What is the prevalence of this? What's the relationship between body mass index and eating? Any kind of question. So essentially, these questions now are usually stuff that you address with a hypothesis. That's why your supervisor might ask, okay, what's the hypothesis? Uh, what is the relationship between this and that? So what hypothesis are you trying to establish? Now, but in terms of machine learning now, there is no need for us to start asking that question, right? So basically, in machine learning, what we are looking for now is we are now asking how can which patients will develop these complications? What will the next month count be next month now? Are you seeing it now? We're not trying to predict the future. How are we now predicting the future? We are predicting the future now based on the information that we got from the descriptive analysis, other types of data, all the things we've learned from, whoever person. So that is just like kind of the difference now between what machine learning and traditional data analysis. That's why most people say, oh, machine learning cannot predict the future. But the problem is that people don't learn from history, and history repeats itself. So what machine learning does is what it still predicts the history based on what it learned from what history. The future is just what a repeating what history. Do you agree?
Yes.
So that is just basically what it is. So what traditional data analysis might do now is you can just tell us what happened last year, predict based on the data we have at hand, that data set we have at hand right now. But machine learning is going to like look at the data you have now, use it to build a kind of algorithm. Then when you now in the future feed in some data into it, it will now tell us that, okay, this is what it will be. Like the lady now that was bitten by a snake. Okay, probably when we get in there, then what happens? From the data that we already have previously, we can now be able to diagnose what it is. Although machine learning can make mistakes as well. That's why we look at parameters like, accuracy and all of that. Definitely going to talk about that. So now, the next part is we're going to now look at some of the key terminologies, right? What are some of the key terminologies? If you're somebody that's getting started with machine learning, because it's just basically the foundation, what are actually some of the key terminologies that we could use to build our vocabulary? Now, machine learning has its own language. Remember, it's just theory. Some of the things you're definitely going to be encountering is we'll be saying using words like data, more like the observations that we can see. It could be data set of clinical markers for cancer patients. It could be a data set for a tabular data set of CSV of diabetes patients that we are enrolled in a facility. It could be a data set of anything. So, but that word data is a dictionary that we're going to be using on the course of this project. And also another one is we'll be using words like features. So now I'm going to explain this very much more in my next session. But then what you will need to understand from this particular insight here now is that look at it as, when we're talking about like the kind of relationship people have, right? So we said so there are quite some features. Now, when you look at the data set for diabetes, now what do you have there? You have some kind of input variables like age, symptoms, lab results, geographical location, measurable characteristics that you might see. Probably, definitely, they are going to be very informative. But essentially, what is are like they are those information that we will use in training our model against the ground truth. Target is what we call the ground truth. So when you get into the hospital, what are those information that the doctor will ask you to bring? What's your age? What's your blood pressure? Okay, tell me about the symptoms. They write it down. Okay, tell me about um do you go to this place? Do you use this thing? Do you do that? All those things are what we call what features in our data set. So when you look at an Excel sheet, there are all those information, all those parameters that you have, age, BMI, this, blah, 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 are all what we call features. But now the funny thing now is that what is now the target? Now the target now is now what we want to predict. Now the target is also found in the Excel sheet, right? So the target now could be your what? Maybe a column where you will now say, okay, this is the lab result, disease present, disease absent, diabetes positive, diabetes negative, if that exists, I doubt. Okay, probably I could use HIV positive, HIV negative. That is the target. So what we want to do now is we want to use this information to understand what the target is. I'm going to show you an example, a slight example now, although I'm going to have more buttress more on this in our next sessions, even during our practicals. But it's just important for us to understand this as a vocabulary, right? Let me just hit something on. Okay, no, I'm going to open. Hold on. I'm just going to open this now. Okay, just give me a data sheet on Excel. Let me just show you something quickly, real quick. Now, okay, good. Okay. Okay, let me just try to zoom in slightly and while I'm waiting for it to load. All right, okay. Let me just use something like, okay, let me just use malaria. Let me use anti, no, let me use malaria, sorry. Let me just use a malaria data sheet in Excel and Okay. Just want to just show you some things and no, no, no. Just to buttress on the point. Okay, so what I'm going to do now is let me just open an Excel sheet. I'm just going to random date. I just want to show you what. Okay, good. Let me just open a real. So now this is an this is a typhoid Excel sheet. Now here, this particular column here, right? We could use anyone here now is what we will call what? Our target. So what we are doing here now is that we are trying to use age, this, right, to predict if this person is infected or not. So what we want to do now is we'll train, the idea behind machine learning is that all these, 1, 2, 3, 4, 5, okay, let's leave this part, okay, because this part now we are encoded, okay. Let's just forget about this part that it doesn't exist, okay. Okay. Excuse me. So from 1, 2, 3, 4, 5, 6 are what we call what the features. So these are the questions that they ask you in the hospital. Remember that the idea behind machine learning is to make prediction, right? So these are what we call the features. And this is what we call the target. So it's based on the information, the information that we'll get from here, that we'll train our model and give it some part of this target. Then at the end of the day, when somebody now comes to the hospital and presents evidence on this, and this, based on the training that we've done, we've developed something like we call a model. Then when we now feed in this data, these three data here, right? No, not this five data here, it will now predict this. This is the target. So that is what we mean by what? Target. I'm gonna go back there. Okay, so basically what target is. So target is the outcome you're trying to predict. Disease present or not present. So present can be 0, absent can be 1. Okay, we'll talk about that in our next, during our practicals, particularly when we work with our project. We'll finish our project basically on time. So the next one is what? Treatment sources of failure, whatever, whatever. It could be binary, it could be multi, it could be, it might not be a binary, target. It could be something like maybe kind of multi-cluster target and all of that. Maybe cat, dog, horse, yam. Okay, that's 0, 1, 2, 3, 4. It could be in numbers, maybe the crypto price here. Maybe here now features is going to be, I'm trying to make you understand it very, very well because it's a very, very important part. Now here now it could be the crypto part, the age of the coin, the type of coin, the profit margin, and all of that. Then this part target is now going to be is going to be okay, probably performance. Now what we'll now do is that the next time now we'll now tomorrow ask the model or I predict what it will be to do tomorrow now or in the afternoon. It will now use based on all the information that it has learned. You tell it, okay, right now, this is what is happening. We have so and so coin, we have this and that. What will the coin be? The target is that coin. It will now tell you, yes, there will be a win. No, there will be no win. 0. So that's what it is. We'll be using these two words very frequently. Usually, features is known as the X. X is usually known as the X. Target is known as the Y. So the X contains usually so many variables, right? But the Y is just one. Then also another terminology we're definitely going to be using is model, right? We'll be talking about the model. Is it the logistic model? Is it the k-nearest neighbor model? Is it the decision tree classifier? Is it the random forest classifier? Is it the neural network? Essentially, it's just going to be comprising of a lot of things. So it's just like the mathematical representation that is learned from data that captures relationship between features and data. And this is what is used to make predictions. So what that model, the whole magic is just that it's just the mathematics. You understand? Just think about someone that is playing sporty bet. Okay, the whole algorithm of mathematics and all of that based on how this thing relates to this thing is going to be bundled together as a model, right? So each time a new user signs up to Facebook and all of there has been a mathematics already. So it's now going to now predict based on the data the person has feeding to now predict the kind of news feed the person will like on the page. It is very, very easy and easy to understand. So another terminology we use is what we call training, right? So training is the process of feeding in data and to an algorithm so it can learn patterns and adjust its parameters. So of course we'll be doing some kind of pre-processing, cross-validation, scaling, and lots of code that we're going to be running. But we are taking it bit by bit to make sure we get grounded in it. Now, another one is what we call prediction. These are just like the dictionary of basic machine learning. So prediction now is just like using that trained model now to estimate outcome for new cases. So we now want to now check with a new data set. Okay, what is now going to be the price of Bitcoin tomorrow, right? Since it is crashing, what is now going to be the price of Bitcoin? It will now say, okay, what are the features now? Because the feature, when you train something, you train the same thing that you use in training it is the type of things you use in making prediction. Let's say, for example, when we are training it, we train it with age. You entered your age, you entered your Gmail, you entered your residential address or your country of residence, you entered your marital status, you entered your age, symptoms, and all of that. When we want to make prediction, we will not just come and enter age and ask it to make prediction. No, we must enter a complete features, right, that matches what we use in training it. So machine learning is just easy. Just like passing in that data again to tell it, okay, is this bacteria or not? That is just what your project is all about. Your project now is all about you passing in that same columns, features now, developing a model where you can now pass it in and actually predict what this thing will be. It's like, okay, this is a cat. Okay, this is Escherichia coli. Okay, this is all that. So don't get scared of all the big, big grammar. It's all simple, right? All the big, big grammar that you see when you come across machine learning, it's just for you to sit down, follow it step by step. That's why we've broken it unit by unit, step by step, to walk into what? Perfection, by God's grace. So these are actually a very massive word that we're going to use in this in anything machine learning. It's a dictionary, is a terminology that is in the dictionary for machine learning models. So basically, what are actually now the real world use case of machine learning? Now let's think about antibiotic resistance prediction, right? And machine learning models transform how we anticipate and respond to antimicrobial resistance, right? So these days, a lot of people are complaining, like the rate of antimicrobial resistance, antibiotic resistance is high. Like so many people now swallowing a lot of like so many antibiotics strains, antimicrobial strains, rather, sorry, and bacterial strains. Think better word to use. Now, basically, what the models we are trying to develop now is we want to actually develop a model that can help us to do what? To identify if an individual, based on the data that they will pass, is resistant or not. Are you seeing where you're coming in as an engineer? So you know, as the engineer, you're trying to know what it's very important that you collect data, right? This is not just garbage collection. This is important. Data collection is very important, right? So we'll collect data. We are working with African Genomic Bank or whatever. So we get the data sheet. We do what corporate processing and cleaning, but that is what we'll do when we come to that stage. But basically, data collection is very important because without data, we can't do machine learning. Machine learning cannot work without data. Machine learning is history. The next thing is what pattern recognition. So it will now learn from the patterns based on the code we're going to write, right? So train the model to identify genetic markers, maybe patient characteristics, depending on whatever thing we want to train it on, right? Then when there is a new infection, the model will now predict the likely resistance pattern within hours before culture tests are available. So before you even start the culture test, machine learning has already performed its due course. And then treatment guidance. Okay. So what do you mean by treatment guidance now? Machine learning doesn't just replace diagnosis. Now, who can tell me the reason why? I want to know. Who can tell me the reason why machine learning cannot replace diagnosis? I want to hear. Empress,
Sir,
why do you really think machine learning cannot replace normal diagnosis?
because no matter what, now it can't be really accurate. I think they might have to need to run some tests on the person. It's just prediction. It's just that AI is just guessing.
Okay, 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 okay. That's a nice point. Any other point? Any other person?
I think because, and also from what you said, and from what I think, I feel medical diagnosis or just normal diagnosis, like it still requires human judgment, regardless of everything. Because in as much as machine learning, recognizes patterns in data and all that, I feel machine learning cannot fully, understand the patients and all that. Thank you.
That was beautiful. Okay. Any other person? I'm sure we are really understanding. Any other person who wants to add? Who else wants to add? Who wants to add? Okay, all right. So I'm going to say something, right? I think that's a very valid point. It can't really understand it, but I think there was one of the points I was really wanting is that there could be a tendency that something new can happen. Have you ever thought about that? Like, because let's say, for example, now we are using machine learning, right? And it's working with data and it's learning from what has been done previously. What about if there is a new strain? What will happen? It won't be able to identify that. Is that correct?
Correct.
Because that's like something new. Because basically,
Mm.
what we are saying about AI, because what ChatGPT is doing is just turning everything everybody's putting on the internet. It has learned from, when someone asks what is malaria now, when you put it on ChatGPT now, a lot of papers has been published on that. So it has been trained with more like, think about it like an encyclopedia, right? So it will just is returning what is already in existence. Another person can put what is malaria again, it will give another output, right? But because there are many, 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 more like it uses what we call this cross matrix. If we really get to the point of, developing highly active chatbots, like you'll see that it's just like it's just returning what is already there, right? So once users are putting in their input, it will be training it on those input until users continue to input. Now the question now is, if there is now something like a new information, because there's always new research. Okay, let's put for example now, in 1980, 81 or thereabout, right? That was when the first strain of HIV was discovered, right? Now let's look at it from this point now. We are using ChatGPT and we now stopped doing new research or new insight. We now start working on historical data. It means that we might miss out on a new outbreak. Is that correct?
Correct.
So meaning that it will just be training on that past data. So it means that it's still important for us to get that uh, as much as we use it to predict, like it's just for us to make diagnosis timely, and also help to improve decision making because when it makes decision and we evaluate the accuracy, we can now say this is what the recall score is. It's just a very simple area that requires some kind of, you know, insight and yeah, understand. So you guys are very correct. So you still need to run, you still need to run tests on the person, right? And yeah, that's fine. That's fine, trust me. But machine learning still stands. So remember we're looking at machine learning for neglected tropical disease, right? Then someone drop something on the chat board. Ooh, what is that? Okay. Okay, so okay, let me use NPN. Okay, that's fine. So, machine learning for neglected tropical diseases, right? So, many neglected tropical diseases with similar symptoms, make accurate disease, and all of that. So, it's just the same thing. We can use it for surveillance, just like I told us, right? So, working on software solutions that can help people to diagnose, have more timely diagnosis. So machine learning is still can come in form of camera lens, right? Empress, you can take a picture of somebody that has some kind of skin rash, and it will tell it this is scabies. It can be accurate, it cannot be accurate. That is the engineer mindset for machine learning. So when there is surveillance or early detection, or when we are trying to get cases in public health, right? Machine learning is very is a very vital tool because it makes it easier for us. There's something we call the epidemiological triad. It makes it easier for us to do what? To identify cases, right? This is actually some of insights that come from what? Pure public health epidemiology. So you still need to actually apply it. So image-based models identify skin lesions, characteristics of cutaneous leishmaniasis. It distinguishes it between different filariasis injections, detect parasites in microscopy. It's just like get into the laboratory, take a picture of the blood sample using a machine learning masked system, and it predicts what it is, what it might be, based on how it has been trained about the features of that particular of that particular organism. So it's a very interesting field that shows a lot of potential. So where machine learning fits in your research, machine learning is not a replacement to existing research skills. I'm sure we are really very much, enlightened about what machine learning means and the destination where we are heading to. It's basically, it's not like a replacement. It's just like a tool that fits in broader analytic pipeline, understands where it belongs to. It's very important for you to understand so that you don't lose sight of fundamental research principles. Just like I asked question that then you said, okay, it's still important for us to perform traditional research and gather new resources, observations. These are quite very imperative for the it's quite very imperative for fitting in any kind of pipeline or developing any model. So data collection is important, is a crucial step. Data preparation, cleaning, labeling, transforming it, okay? It's something you're gonna learn because basically now at this stage of your project, now what you're thinking about is how you can work on a data set and get the maximum insights out of it. Training the model, fitting the models, and validating it is a very crucial step. Prediction generation and producing the model for analysis or deploying it, shipping it for, probably you can ship it for development or further use, and that's maybe probably to some servers, DevOps rules, and all of that makes a lot of sense. So that's like the pipeline. So some of the common misconceptions is that most times I do post, oh, I've trained a particular data set with 10 models, 20 models, 30 models. Truth is that more models doesn't mean better result. That doesn't really mean that I have a better result or something. Okay. Because basically, the more models that you have, which we're going to talk about, don't worry now if you might not really understand what the models are. This is just for you to understand what the idea of machine learning. So more models doesn't mean better results. It doesn't. Okay, so building 10 different models doesn't guarantee that you've made better predictions, okay? So often when one is well chosen, if you use the right one, it's just like now you're doing something like a tabular machine and you're using neural network, we'll be like, guy, is that not too heavy for this? That's too heavy for it now. Like something that you would do with a logistic regression, you're using something so complex like a neural network or that kind of stuff. So it doesn't really, that doesn't mean that, okay, yeah, you've used the best, you know, model. Okay, that means it's replaced now. So that's not how it works. So, yeah. So, or you maybe use 10 models. I use naive Bayes, scaled logistic regression model again. Maybe on top of it, I have decision tree classifier, random forest, lots of them, and then support vector machine too. And yeah, K-nearest neighbors. And then all of them packed it for one data set because in your data analysis, these are some of the things you'll be looking at. One person here, some of us here will use different models. One person might use support vector machine, the other person might use logistic regression, the other person might use k-nearest neighbors, the other person might use because basically our data set is going to be different. So you need to understand what you're doing, what you're signing into, so that while you're working on a project, you're deploying, you're shipping it out as well for people to also test their data set with your model. And I think at some point I might teach you guys version control, how to use, Git, how you can commit and push, and also fork, your repositories and all of that. So those are very, 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 very important. So another misconception is machine learning replaces domain expert. Nah, we already argued that here, that human experts cannot be replaced by AI. Algorithm doesn't understand clinical context. It doesn't understand emotions. Machine learning is just the robot that is standing in China. All those things are trained by models. Do you understand? They are all trained by what? By models. So it doesn't really mean that. It can understand emotions because it can ask it, if you turn your left, give it a hot slap, else return this. For iron that, give them 10 slaps. And that's like a logic that I've already like said now. So then when you turn, it doesn't, oh, you're feeling this, it gives you a slap already. So yeah. So that's why it's important for us to still have some kind of human input and all of that. So bigger data always means better models. That's a misconception. Data quality matters more than quantity, right? And I can work with 9,000 data samples, and it doesn't really mean if the data are not properly like, it doesn't mean that, okay, you have so much data, that means best models now. So data quality matters more than quantity. Just get the gist here, okay? Then there is also what we call black box model, are always opaque, right? So why some models are harder to interpret than others? Modern tools for modern explanation can reveal what complex models learn. So interpretability is a spectrum, not a binary, and it's your responsibility to understand your model. So the problem is that most times people struggle with interpretation. So at the end of the day, when we are done predicting it now, you can't even interpret it. So the idea now is that having a very good understanding of your model is going to play a very, very massive role in machine learning. So, excuse me. So what's this training going to teach you? We're going to actually look at practical explainable machine learning models, applications in public health research. Basically, beyond public health, it also applies regardless of any discipline. Okay, so how to prepare and explore data for modeling, training, evaluating, interpreting. We'll have hands-on Python coding for each step of the workflow, real examples using antimicrobial resistance data sheet. NTD data sets, critical thinking is very, very important. So we won't really cover advanced mathematical derivation of algorithms. So more like uh, I'm going to make sure you guys understand some of the concepts without using calculus, because if I want to run the model from scratch without using something like scikit-learn, I can use calculus, to run the maths on Python and then develop the model. And then for now deploy for data set, but we'll keep it simple. I'll make it very, very, very simple for you guys. We'll just show you the models, the existing frameworks, because there are a lot of libraries that is going to help us. Libraries like scikit-learn, uh, we've got TensorFlow, we've got Matplotlib, Pandas, NumPy, but TensorFlow is my behavior. I don't think we might really go into that. But scikit-learn is very, very okay. That's what we're gonna be working with. And deep learning, neural networks, no, those are gonna require extended training. Product deployment, software engineering. Our focus is just on applying it on research, and every possible algorithm will prioritize methods without the one that is most relevant to your work. So this is what your learning journey is. I think I've already outlined that. You need to make sure you're working on projects, because we have like 8 weeks, okay? So from our first 1 to 2 weeks, we'll look at programming basics, data structures, essential libraries like NumPy, Pandas. I'll definitely make videos, and yeah, it's going to be really hands-on. And after our next session, I think the next upper session is when I'll teach us some kind of installation, how to install Python 3, maybe dots, how to actually install the dependencies. Excuse me. And basically all the relevant packages that you need for you to work on this project. Installing Pandas, getting started with Jupyter, Google Colab, and all the environment. Then in our fifth to sixth week, we'll look at some of the core machine learning concepts, training and evaluation, workflows, cross-validation, performance metrics. Week 9 to 10, applied project. We'll start working on our project immediately. And then week 3 to 4, data preparation, common algorithms. Okay, I think I actually skipped that. Okay, then after our first week, we'll get to data preparations. Then we'll come to core machine learning concept. I'll explore some slight mathematics here, which is important. Then we'll look at some of the common algorithms. Then before our week 9 to 10, we'll work on our project. And yeah, so uh, I feel like it's very important. Each week, each week is just basically 10 to 12 hours each week, right? So our classes is just uh, holds every 9 p.m. And yes, every 9 p.m., 9 p.m. and 9:30 p.m. Yeah, that range. And also, as usual, we would be moving into the next phase. So I'm sure we understand that there is really no time for uh, you know, blockbuster delays, because already it's just like the Premier League. The matches are already fixed. So you're seeing the matches. You know what we have the next day. You know that if we meet the next day, we can't meet up with the next day. And that way. So it means that we must make sure we continue running on it till we get to the last day and all of that. So I want to actually say a very big thank you to you. Like I said, I also make videos. Of course, lots of them will be committed on some of the data codes. I'm going to be committing them on my Git repository. I'll teach you how to use that version control. And yeah, maybe some kind of added or whatever, if that's the best word, for you guys to explore the very best out of this course. So I just want to say a very big thank you for this time. So this is just some philosophies that I actually expect you guys to use. One of the ways you need to get very good with programming, machine learning is that usually after each of these classes, you need to just kind of go through the slides, go through the insights you're already on the group chat. Of course, definitely share the slides there. You go through them. You also, yeah, relate it to your project, if you're working on a project, but it's quite very important that you go through the slides, and they are quite important. and then you try and practice it. So what some of the exercises that I'll leave with you for now is just for you to go back and look at some of the basics of machine learning, try and understand it very properly. And yeah, of course, I'll be making videos I'll put on my YouTube for better consumption. So machine learning is easy. I just want to let you know that. It's not something you need to struggle with because a lot of people struggle because there's no clear pathway. I used to say that most times what people pay for is not really the information because the information is on YouTube. What people pay for is the direction. That's the direction, and the what? That's that's nurturing. Do you understand? Because if not, all these things are all online. All. But the lack of discipline is crazy. And the distraction is something else. It's really, really, really bizarre. Like the distraction that we have now is mind-boggling. So, and most times I question people's studentship because it tells a lot. Okay, so it's really going to be something challenging now. So you need to now challenge yourself. Look at the hours you spend on social media. Think of how much you would delegate to practicing. Yeah, if you're a student, okay, when you finish from school, when you finish from a job or finish from whatever thing, how much time are you now going to delegate to machine learning? Maybe an hour per day, is that okay? Maybe two, is that okay? 30 minutes, is that still okay? Because if you stop it, it will forget you. That is how programming works. You don't stop. You must continue. Because if you stop, it will just, you see yourself from the basics and you struggle. So I don't know if what I said has any relationship with the slide that is pointing at my face right now, but what this talks about is thinking critically about machine learning, ask about bias, you ask me questions, consider fairness. Okay, these are actually more of what you need to think about when you're trying to perform any kind of machine learning model or whatever. So, right. So it's important you understand that it is bias is important to assess, fairness, demand transparency and all that. So there are quite some parameters that you need to actually get into for this. So it can feel overwhelming, but that's not normal. That's normal. Everyone in this training is navigating the same challenges. We are building a community to support each other. From our second company, it's analytics, where we are working on developing explainable machine learning technologies that can be scaled. So yes, sorry, excuse me. So definitely I'll be reading materials, curated articles, which is from these notes and. Yeah, and also some kind of live sessions and all of that. So I still have some other things to leave with you. Expectations are best practices. Consistent practice is going to help. Active participation is going to help. Go over this video again. Go over it again and again. Make sure you cement yourself to what you've learned. And yeah, it's important to be confused. Confusion is not a problem. And yeah, so connect it to your work as well. So make sure you engage in discussions. If you're feeling lost, it's part of it. Confusion means that you're pushing beyond the boundaries and consistently ask yourself questions and all of that. So what do you guys remember from today? First of all, machine learning is about pattern recognition, right? Remember when I gave an example about your ex, how you learned a lot of things from him, you got his name, you got his, a lot of things basically, and you learned, you're already a working algorithm. Okay, you're a working algorithm. So it means that what a new data means that is when somebody now comes to meet you, is a human being that will meet you now, is not a goat. What trained you? Right? What trained you as a working algorithm was a boy. So he was a human being. That's the features that he came with. He has an ear, he has an eye, he has a character, he has an age, he has a lot of things. So those things are features. So when we want to now test if you should be able to detect a simp or a non-simp, we will not give you a goat, right? We'll still give you a human being, a boy. We will not give you a girl if you're a girl, right? We will not give you a boy if you're a boy. right? We'll still give you the same that type of human being that they use that showed you sugar. Then you now look at it, you look at the person and now class, okay, this person is a good person. Okay, no, this person is a bad person. That this is just what machine learning means. When we want to train a diabetes data set, right? Now the outcome is infected or not infected. That's our target. Now, essentially, what we do is that we train it with features, right? Now look at that your topic now, AMR, blah blah blah, long English that is very confusing but simple. Now, basically, what we are going to use in training that model is just that we use those features that we get from the biobank, from that data set, to now train it. Then when we're now done training it, we'll now say, okay, we'll now pick like a kind of a model. Sorry, not a model. We'll pick like another feature that resembles that same columns, that features, and I'll pass it into our model. And I ask, okay, now predict, does this person have antibiotics resistance or not? It will now look at it based on the patterns it had learned from the past and now predict this person has. So that is just how it works. So the example of the guy is a very good example that you can use and memorize. And basically, it's going to make a lot of sense. So you need to be very critical think. You need to be a critical thinking while you're a programmer, right? As an engineer that you are, public engineer or whatever, blah, blah, blah. You need to be really critical. Context matters more than algorithms. Learning is a process. You won't master everything immediately, of course. Yeah, that's why it's 2 months. Okay, it takes time. We start today, we continue running till at least we get to some point and all of that. So looking ahead, our next session, we're going to be looking at we'll be looking at some kind of data types and all of that. Not this, and yep. So we'll be looking at data types and all of that. So you check your outline and you have all the insight that we've got to discuss. So I want to say a very big thank you. Are there any questions that you guys want to throw at me for now? Or tell me your reflections about the session?
The session is actually nice. I don't have any question. Okay, I have a question, but it's not related. I want to know the next time for the class. Is it still tomorrow or next tomorrow?
I don't think that's a proper question because you have the outline. So it's clear there.
Okay, so
Okay, so is there any other question? Maybe.
None from my end.
Okay, so I'm sure you understood how machine learning works and just the idea behind it. This is just the theories. Theories is usually very sweet. But but trust me, theories is sweet, but it's important because the reason why the theories are quite important is that it just gives you a kind of a scratch of what it is. And trust me, the practicals is just simple when you understand the theory because it's now more like now implementing it in code, and repetition will help a lot. When you continue to repeat, to be doing it again and again and again and again and again and again, continue doing it. You understand? Once you continue repeating it and all of that, you don't need to be scared about anything. It's a very simple thing. Sometimes you might see somebody, this person is already doing classification using neural networks. So I want to leave this one to jump to that, you will just collapse because number one is that the way we designed it is that you build from basics as if you've not done it before. So when we'll be talking about data types, you need to still pay attention very well. You understand? There is no particular part that is not important. All parts are important. Because if you don't pay attention to that part, or maybe you enjoy then the next one, you want to now go to the next one, you will struggle in that one. So it's just that it's going to be very simple and easy. So when we're done with the next part, then you understand data types. Okay, what is data? What is this? And that next part now is more of data analysis, right? And everything you're going to get from there is just fully data analysis. So when we're able to crush that part of that data analysis, it means that forever you've understood it. Even if you now decide to switch to data analysis as a career path, you have insights that forever in your mind that you will get from there. So it's a very simple discipline. Don't get scared. A lot of people would say, "Oh, machine learning, this one, that, and all of that." Even deep learning is simple as well. It's simple because all the whole idea is just this same one sentence: predict what that boy has done, and then when you now meet another new boy, when he now acts, you now be able to classify where he belongs to. Do you understand? So you might be wrong because why might you might be wrong because probably the way the previous boy trained you, there might be some kind of inaccuracies, right? Maybe the time he told you that he didn't really cheat, you thought he was lying, and with that you now carried in that data, or maybe his communication was faulty. So that's a kind of that's what we now be doing what we call accuracy of the model training of the that's accuracy of the models. And something also we call precision. Okay, so when we now get all these parameters, when the other boy now meets you, because of the inaccuracies too, you might not rightly predict him correctly. You might be saying something correct. You might say, okay, predict what is this picture. You look at the picture and say, this is a cat. Whereas this is clearly a lizard. Or maybe not a cat, maybe I think the better word to use is this is a lion. Because lions are more of big cats. Or this is a jaguar. And your model is predicting it to be a cat, kind of a domestic cat. So that is just what machine learning is. So it's just for us to now understand, hyperparameter tuning. Oh, we don't really go into that. That's like a very, which is simple as well. It's just simple, but all these things are just terminologies that will make you tune your model up. Make sure your model is properly scaled, is not shouting. There's something we call your model shouting, and all of that. But trust me, we are going to walk through the basics, and I'm sure that by that next month, you guys are going to be certified engineers for machine learning. And yes, and that means you'll be very capable to get a certification from our company, Synalytics. So I want to actually say a very, 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 very big thank you to you guys. I'm going to commit this on YouTube, particularly if you want to have some kind of refresher. And yeah, you can always exploit there. And of course, I'm going to personalize the link, and it's just going to be for the viewers. That's for you guys and all of that. So in the absence of that, if there's still no question, I think we can call it a day. And then if you've got any kind of proposal, you can send it to my DM. Definitely I'll make some comments on it and all of that and all of that. So I think that's actually it. So yeah, thank you very much. Thank you for your time. Thank you.
Thank you, sir.
Thank you, thank you, thank you so much. This
Yeah.
was an amazing class.
Okay. Yeah. See you guys in the next one.
All right. Good night.
You are impressed.